The camera wasn't working. So, yeah, it's live again. My 12th live stream, I think, now. So this is paper 3. This is a reasoning paper, okay? So in the SATS paper, it's soon this week, the SATS exams. So paper 3 is the third paper, and you have 2 reasoning papers. So the first 2 are your basic, well, your first one is arithmetic, and the second 2 are reasoning. So lots of worded questions, but really important, gets revision. Let's go for it. So, as before, you got this random stuff here going on. Just make sure when you do your papers this week, you are writing your answers in this box, okay? So, let's have a look at question 1. Like with my other live streams, I'm going to put chapters on after this, okay? I won't guess to do it straight away, but I'll put chapters on each question. So you can go straight to that question you want when you watch it again. So, first question. Here's a drawing of a hexagonal prism. So I'll go a little bit closer on the camera there so you can get a good view. Hexagonal, basically think 6 sides, okay? Hexagonal because it's a hexagon at the front. It's a prism. That means it is 3D. So, hexagonal prism, how many faces does the prism have? Faces are each of the 2D shapes on the 3D shape. So one here. The trick is here, remember, one at the back. So that's already 2. And then you've got these going round here. So you see 3 here, then there's going to be another 3 there. So that'll be 6. So altogether, there are 8 faces. Yeah, nice and easy, 1 mark. Let's go to question 2. Right, number cards here. So you've got your multiplication here. Use all 6 cards to complete the 3 multiplications below. This is where you can use each card once. So 6 cards, 6 spaces. And you kind of got to see what goes together. First, probably a bit of trial and error. Like I can already see there's a few different combinations here. And you can just move them around as you go if you need to. So for 24, I'm going to use 3 and 8. No particular reason, just I know that that works. You could use 6 and 4, but I might need them later on. So it's 3 and 8 done. I'm going to cross them off as I go. For 28, I'm going to use 4 and 7. And for 30, I'm going to use 5 and 6. Yeah, that is it. I've used each one only once. That is question 2. Right, let's have a look at question number 3. So, worded problem again, involving money. So, Olivia buys a banana, an apple, and a bag of nuts. Just to remind you, these questions are all non-calculator as well, okay? So, all SATS papers, none of them you can use a calculator. It's only when you get to GCSE. However, questions very similar to this are on GCSE exams right at the beginning, so it all ties together. She pays with 3 50p coins. What is her change? So we know 3 50p's, 3 times 50p. That equals 150 pence or £1.50. So that is what Olivia has. Now, total of all these. Look at this, it gives you these boxes here so you can add it all up. So we can do 60. If you keep it all neat, it'll make it a lot easier. So keep it all neat. 60, 45, and 30. Add them together. So that'll be 5, 7, 13. So now it's 135. So that's 135 pence or £1.35. Yeah, so the difference between £1.50 and £1.35 is 15 pence. Okay, right. Question number 4. I'll get the camera a little bit further back so you can see it all. A little bit more here. There you go. So draw 4 lines to match each fraction to its equivalent decimal. So notice here, it's give you 6 options, but only 4 fractions on the side here. So you can wing it a little bit and you might get the odd one right, but we need to try and be as accurate as we can. So 1/2, most people know this one is 0.5. Okay? 3/10. If you know your place value, so you know if you have 0. Let's say if we add 1, 2, 3, 4, well that's your units, that's your tenths, yeah, the first number after the decimal point. So if I've got 3 of them, I'm looking for a number in that position, yeah, and that is 3/10, 0.3. 3/4, well, to remind you, 1/4 equals 0.25. So you can see that's there, but I've got 3 of them. So now that is going to be 0.75. And 3 hundredths is going to be this one here. Remember, this column here is the hundredths. So 3 hundredths, that will then go to there. Nice and easy. Right. Question 5. Right, some children vote for their favourite ice cream flavour. Vanilla, chocolate, strawberry or mint. They should really have an other column because some people might not like any of those. So, see here we have 3 numbers and we have a total, but we are missing one. So we're going to have to add those together and take it off there, okay? So firstly, add them all together. Put your biggest number at the top. Not essential, but will make it a lot easier. 87, 38, and then add down. So 4, it's 11, 19, and then 5, 13, 16, 17, and 1, 2. So that's 279. So 279 plus something makes 402. So now I'm going to go 402, subtract 279. Be careful here. Don't do 9 minus 2. Yeah, it's still 2, subtract 9. But you can't do that, so you go here, right? Because that's a 0, you can't do anything with that either. There's nothing there to borrow from. So I'm going to go over again, across a 4 to a 3, and put 1 there. Now I can borrow from this. So 2, I can borrow from the 10, and that becomes a 9. 1 here. So 12 minus 9, that is 3. 9 minus 7 is 2. 3 minus 2 is 1. So we'll know that is 123. Now let's look at question number 6. So this chart shows the range of temperatures each day during 1 week from Monday to Friday. Yeah, definitely it's based on the UK, this, isn't it? Look how cold these temperatures are. Right, Monday, Tuesday, Wednesday, Thursday, Friday. It's a weird graph. So what was the lowest temperature? Well, we're going to go look at down this end, aren't we? So we're looking at these two here, which are the same. And we can see it's going up in 1, so that'll be minus 8, that'll be minus 7, minus 6, minus 5, minus 4, and so on. So we know they're the same, so it's minus 7. Right. The question down here, I'll go a little further back so you can see. What was the difference between the highest and the lowest temperatures on Wednesday? So this is where it comes to our graph on Wednesday. I'll go a bit more here. I'll do this little zoom in and out every now and again to make it easier. So Wednesday, come up here, and that's minus 5. So no, that's minus 5 there. You can write all over these graphs and tables. Yeah, it's absolutely fine. Depending on the exam, you might even get marks for it depending on what it is. But yeah, you can do that. It's absolutely fine. So that's minus 5. Come to this end, 2, and that's 3. Remember, it's going up in 1s. So now I need to know the difference between minus 5 and 3. So minus 5 to 0 and then to 3. Well, that is a difference of 5. And then that is 3. So altogether, it's a difference of 8 degrees. Right, question number 7. Yeah, students normally do struggle with, well, directed number is called, what negative numbers you might know it by, do struggle with that. Oh, question 7. So one Saturday afternoon, I'll go a little bit closer here so you can see. A total of 234,869 people attended 3 rugby matches. Those on watchers not from the UK, rugby is similar to American football, just a little bit better. That's a slightly different game. Right, 80,000 people attended match 1, 72,000 something attended match 2. How many people attended match 3? Well, these two totals plus something gets me this. So I'm going to have to add them and take it off this. The difference between this, in the arithmetic paper on paper 1, it'll just give you that sum and you just have to add it as it is. Whereas now it's worded form, you've got to figure out what the question is asking you to do. Oh, let's add them together. And we use the boxes, it'll make your life a lot easier. And down, across, so 8 plus 9, 17. 7 plus 1 is 8, add the 1 is 9. 9 plus 3 is 12. That is 3 and 15. So 153,297. That is a total of those two. So now I'm going to take that from this. And just like before, keep all your numbers in order. So many times I've seen students lose marks by just not being careful when they're putting the numbers in order and trying to keep them really in line, that column. 1, 2, 9, 7. So we're going to subtract those from each other and then just go down. 9 minus 7, you can do that. That is 2. 6 minus 9, you can't do that. So that becomes a 7. Taking 1 here. 16 minus 9 is 7. Minus 2 is 5. 4 minus 3 is 1. Can't do that. 30 minus 5 is 8. 1 minus 1 is 0. So our answer is 81,572. All right, question 7. Right, sorry, I just given a number here. I first didn't think there's going to be anything to do with it then. But then the question is below the number. So 7,546. So we're going to have to do 3 different options it wants us to do with this number. So round this number to the nearest 1,000, to the nearest 100, to the nearest 10. Well, 7,546, that is closer to 8,000 than 7,000. So it's going to go to 8,000. So it's 100. Well, your answer is either going to be 7,500 or 7,600. And it's closer to 7,500 because it's a 4 as well. So that means 4 below, you stay as it is. 7,500. And so nearest 10, it's either going to be 7,540 or 7,550. But it's closer to 7,550. So it's going to go to that instead. 550. All right, next one. Question 9. Right, so 1,000 multiplied by 416 equals 10 times something. So what I'll do this one, I think people could overlook this quite quickly. I would just work out that first. So that is just going to be 416 and add your 3 zeros. 1, 2, 3. So now I've got to think 10 times something to get with that. That's going to be 4,100 or 41,600. Alternatively, I could just do that, divide it by 10, and that would get me that answer. A little trick you could do there. All right, next one. So that was question number 9. We're going to go on to question number 10 now. If you do have any comments, do let me know. Do ask me any questions to do with maths, and I'll do my best to answer them. Okay, so question number 11. Ali chooses a whole number. When she multiplies her number by 4, I'll go a bit closer here. The answer is less than 100. When she multiplies her number by 5, the answer is greater than 100. Well, the way to do this, I was thinking about this earlier today, as you do, think about maths during my day. I would think, well, firstly, what's 100 divided by 4? Well, I know that is 25. So the number can't be 25. It's going to have to be smaller than that, because otherwise I'm going to get an answer of 100. So I can just use the number 24. Because now I know if I do 24 multiplied by 4, that's going to get me 96. And 24 multiplied by 5, that is going to get me 120. Yeah? There's probably a few more answers. You probably have 23, 22, 21. Yes, you could have 24, 23, 22, or 21. 20 wouldn't work because 20 times 5 is 100. Yeah, so you could have 21, which should work. 22, 23, and 24. Yeah, 4 different answers you could have. Question number 12 is the next one. Fractions. This is what students really struggle with. Questions like this are even on GCSE exams as well. Yeah, it's not just Key Stage 2. I tell my students all the time, these questions are on GCSE as well. Just they look slightly different, but the skills are the same. So it's so important, okay, that we really understand and we get this down. Right, 2/3 plus something is 5/6. It's going to be easier if you convert that to sixths first, okay? So 2/3 is the same as 4/6. So you're thinking 4/6 plus something equals 5/6. So I can see there it's going to be 1/6, isn't it? Yeah. We've got to do that conversion first to help you see it. All right, question 14. Jack hires a hall for a party. This formula is used to work out the total cost. So £15 booking fee, Pretty standard, actually. It relates to real life quite well, this. Plus £12.50 per hour. What is total cost from hiring the hall from 6 p.m. until 11 p.m.? So it's testing your skills of time here. 6 to 11, that is 5 hours. So it's going to be £15 plus 5 hours something. So you're going to think £12.50 multiplied by 5. Okay, so that is 60, add on 550p, £62.50. That'll be £62.50. You can set this up in column multiplication if you want to. That's absolutely fine. Right, and then we've got our price here. Now we're going to add on our booking fee. Okay, really important. So that's add on our booking fee. So that equals £72.50. If I am wrong on the answers, do put it in the comments and let me know afterwards. You know, you can point me out and shame me. That's absolutely fine. You never know. Even maths teachers get it wrong sometimes. Right, question number 15. So there's a lot less questions in the reasoning papers because they are quite wordy. There are a lot less questions. There's not as many compared to others. Right, question number 15. Let's zoom back out a little bit so you can see. So instantly, people might start panicking because it looks a bit weird, but it's not as bad as you think. You just read the question, take your time. Stefan, I think it says, stands in the centre of this square. Right there, that's where he is. Stefan is facing towards F. So Stefan is here. This is my stick person right here. And he's facing that way towards F. He turns anti-clockwise. Other parts of the world, in America, you might call it counterclockwise. Same thing. In the UK, we call it anti-clockwise. Other people might refer it as counterclockwise. Same thing. Right. He turns anti-clockwise face D. So he's here. He then turns anti-clockwise. So that is anti-clockwise. Yeah, it's like going against the clock. And then that way is clockwise. Now it's going with the clock. Okay. Right. So anti-clockwise, so he's gone here, he's gone to there. What angle does Stefan turn through? So that is a 90-degree angle. Yeah. Because each of those points, it's 45, 45, 45, and so on. Yeah, that is a 90-degree angle. Yeah, we should know there's 360 degrees in a circle. That is 90 degrees. So next question. I'm going to read it, then I'll zoom out a little bit in a sec so you can see more of it. Stefan is now facing towards D. He turns 3 right angles clockwise. Write a letter he faces after the turn. So now he's turning 3 right angles clockwise. So he's here. So he's going to go 1 right angle, 2 right angles, 3 right angles. So now he's facing towards B. So he's going here. He's going all the way around to here. Alternatively, if you're going to be really clever, you could just do 1 right angle anti-clockwise. You're going to be really clever and do it quicker. It's big. Some people, some of you there, mathematicians, might see that straight away and get onto it. Question 16. So part of this 10 by 10 grid is shaded. So if it's 10 by 10, just to clarify, I might not ask me a question about this yet, but I know that's 100 squares. Yeah, 10 times 10. I just might need that information in a minute, but I don't know. Is shaded. See here. So I've got 4 columns shaded. Each column there is 10, just so we know. So what you can do, just to make it easier, 10, 10, 10. And now that is 40 over 100. I've not even looked at the question yet, but I can use that information to help me. Take the fractions that represent the shaded part of the grid. So now that's 40 over 100. Well, that's the same as 4 over 10. And that's also the same as 2/5. For a second, when I read the question, the 4 10s 2/5, because it says 2 fractions, take the fractions, I know that's more than 1. Whereas if it said take the fraction, I would have got a bit confused that it's got 2 there, but because it says fractions, so there's more than 1 answer. So we know it is 2/5 and 4 tenths. Oh, and in addition, 40 over 100. So because I've done that to begin with, it got me the answer already before I even properly looked at it. Right, question 17. We're almost there. Oh, question 17. Kim makes a cuboid with metal straws. Why Kim would want to do that, I don't know, but maybe she was bored one day and just felt like playing around with some metal straws. And yeah, we can't use plastic anymore because the government got rid of all them. So, save for the planet, that's what she was thinking about, the planet. QM model using straws. I see we have a cuboid here, height, length, width. Sometimes the width that's referred to as a depth. Same thing, doesn't matter. Choose straws that are 7.5 centimeters long for the height. So I know that is 7.5 here. If you fill in information as you go, it's going to make it a little bit easier, okay? Because then you can use that information later on. And it's breaking the question down. So I know that's the height there. I know that there is going to be 7.5. I know this here is going to be 7.5. I know that there is going to be 7.5. So to make it a bit easier, I'm just going to add them up already. So instead of doing it all later on of all these sides, I'm just going to do that one quick now. So I know that is 30. Yeah. She uses straws that are 11 centimeters long for the length. So that's 11. Remember, that one's the same there, 11. That means that one's going to be the same there. It's 11. Nope, not that one. Almost then. And that one's going to be 11 there. Yeah, be really careful. 11, that's the length as well. And them two. So that's 4 11s. That's 44 centimeters. 8.5 centimeters long for the width. That's 8.5. 8.5. 8.5. Got any more? 8.5. So it's basically 4 of each, isn't it? Just to clarify where I've got 30 from, that was 7.5 times 4. That was 11 times 4. And this one is 8.5 times 4, which is 34. No. Yes, 34. I had to question myself then. 34. And now I'm just going to add them together. So 30 on being naughty. I'm not putting the biggest number at the top, but for this, it'll be fine. It'll work itself out. 8, 7, and that is 10. So 108 centimeters. Whew, my wrist now, that one. Took a bit of writing. Yeah, you know, if doing the exam, you might not be that excessive, right, that much writing, but it will help you as well. It would just break down the questions. That was question 17. Question 18. Oh, a sale's on. Love a sale. Right. T-shirt, £15, reduced by 30%. So the full price of a T-shirt is £15, not anymore. This cost of living. I wish. The price is reduced, so that means it's going down, because it's a sale. Prices go down in a sale by 30%. What is a reduced price? So if you've gone into the shop, Primark, of all places, £15, right, 30% off. You need to know how to work that out, okay? You don't want to be ripped off. So 30%. Well, 100% equals 15. So then easiest, find 10%. So 10%, we'll divide it by 10, is £1.50. So I want 3 of them. 3 10%. Because 3 10% will get me 30%. So if I add all them together, that'll be £4.50. So then that's my discount, £4.50. Take that off the full price. So then I'll just do £15 minus £4.50. You don't have to do column subtraction every time. If it's something you can just work out quick, just work it out. So now that equals £10.50, because you are tired on these exams and you don't have time just to daydream and dilly-dally around, okay? That is £10.50. Yeah, just work it out, get the job done. Right, question number 19. Let's go. 19. Jack, here we go. What's Jack saying? When you square a prime number, key information there, the answer has only 2 factors. This question, we have to understand what a factor is. Quick demo. A factor are pairs of numbers that go into a number. So, for example, the factors of 10, because 10's a nice easy one, are 1, because 1 times 10 is 10, and 2 and 5, because 2 times 5 is 10. It refers to integers, whole numbers, okay? That's what factors mean. So, now you've got to think about your prime numbers. I'm going to give you the first 10, and then you can think about these, okay? So, the first 10 prime numbers, so you've got 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. They are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, first 10 prime numbers. So when you square a prime number, the answer is only 2 factors. So squaring means times it by itself. So what I'm going to do, I'm going to square a number and see how many factors it's got. There's actually, you can prove this quite quickly to this theory. Just if you square 2, you will get an answer that has, well, actually 3 factors. So actually any prime number really works for this one. I'm going to take 2. I'll do it with a couple so I can see. 2 squared, so that's 2 times 2, which equals 4. And 4 has 1, 4, and 2. So that has already proven the theory wrong. We'll do it with another number just to make sure. 5 squared, which is 5 times 5, which is 25. 1, 25, and 5. Yeah, so already you can see it's proven it wrong. Right, I think the last question. Oh no, a couple more, 2 more, sorry. 20. So 2 more questions to go. This is on question 20 now. So we'll zoom in a little bit just so you can quickly see here. This table shows how many people finished the New York Marathon in each of the first 4 decades it was held. Okay, so these are attendances who finished the race. Here, what is the mean number of people who finished the marathon per decade? Round your answer nearest 100. So mean is when you add all the numbers together and divide by the amount there is. So we're going to have to do a bit of calculating here, okay? So yeah, we need to remember what the mean is. So first, we have to do some adding. So 350,824. Luckily though, the mean is when you add them and divide by the amount there is. There's only 4 amounts, so dividing by 4 is not going to be too bad. 282,420, and then we've got 170,932. The only thing is, they put this question on there because people are going to go wrong in this part here when they are writing all these numbers out. So that's 6, 9 there, 4, 7, 13, 8, 12, 21, 29, 30, 6, 9, 13, 20, 22, 5, 6, 8. So I've got an awkward number here that's going to be. Round Johnson is, let me double check this number, 6, it's 9, 4, 7, 13, 12, 21, 29, 30, 6, plus that is 9, 13, 20, 22, that is 6. Double check that then, because when I divide that by 4, I'm going to get an awkward answer. That's why I question that then. So let's do bus stop division. 829, 039. Divide that by 4. So, actually, yeah, could be. 4 into 8, that is 2. Over 429, that is going to be 7. And 1 left over, that'll be 2 and 2, that'll be 5 and 3. And that is going to be 9 and then 3 left over. Right, I'll do that just so you can see that's going to be 7 and 2, and that'll be 5. Right, it says it's the nearest 100. So, where's the hundreds column? Units, tens, hundreds. So then 5 against a 2. So it's going to be 207,300 as your answer. That is a really awkward question and quite time consuming. You've got to be really accurate with your numbers on that one because that can take some time, and I can see why people will make a lot of mistakes on that question. Right, last question, question number 21. And this last question, I could see this being on a GCSE exam, to be honest, because it is it can be tricky to begin with if you don't read it carefully. So these 2 rectangles are identical. In GCSE exam, it will say congruent. That means exactly the same. But identical is saying it means the same, exactly the same. So the length of each rectangle is 3 times its width. So the width is 2, the length is 6, the width is 4, the length is 12. Yeah, 3 times. Key bit of information. Really helps if you know your coordinates in this as well. That's 0, 1. So it's 0 there. Remember, that's 0. It's gone up 1. with the coordinate, that's the x-axis, that's the y-axis. 0, so that means that point there is 1. This here is going to cross here, so that is -2 there, that point. Well, that's 1, so I know that is 8 there. Okay, so just picking off bits of information we know. -2, 0, so I know this side is length 2. Yeah? So if that's 2, I know that from 2 to 8, yeah, because it's 3 times its width. That's why, because 2 times 3 is 6. So I know this here must be 6 its length, okay? If you want, it might help if I draw on it here. So that's a bad rectangle. So that's 2 and that's 6. 6. I don't know why I say 6. So no, if that's that bit there, that's 2 going across as well. That must be 2 there. So it looks a bit like 22, that does. That's a rectangle. So then, now I need to know these points. So that's 1, that's 2. That must mean that is 3, and that's going across 6 there. So this, it's 6 across and 3 up. That is a bit of a tricky question, and I can really see that on GCSE exams and even GCSE students struggling with that. That is it. That is Key Stage 2, Paper 3, Reasoning. This is all from last year as well, really important. The questions did change a little bit, but the skills are the same. Thank you for watching. I'm Master Jacko,